Now that we have this trick for separating separable equations, it's sort of easy to fall into the trap of thinking that we can solve any differential equation, at least any first-order differential equation. But that really isn't the case. There are some problems with this trick that we have for separating variables, some ways that this trick can fail. So let's have a look at that. So let's look at this example. dy dx equals e to the minus x squared times sine of y squared. So we could start out by, I guess, separating. So we're going to get 1 over sine y squared dy equals e to the minus x squared dx. Okay, now we need to integrate on both sides. And, well, this is where we run into a problem. Because this integral on the right, this is one of those integrals that's impossible to do. There's no formula we can write down for the antiderivative of e to the minus x squared. I mean, you can name that function, but naming it isn't really the same as having a formula for it. So, you know, at this point, we can't do this integral, right? And in fact, on the left-hand side, the situation is just as bad. We can't do that integral either. So, even though we were able to separate these variables, right, because we can't do these integrals, we can't actually solve this differential equation, at least not exactly. So we aren't going to be able to come up with a formula for the solution to this differential equation. Right? So that's one way that even if you have a separable equation, you might not be able to solve it. Right? Solving a separable equation involves doing some integrals. If you can't do those integrals, you can't solve the differential equation. And I'm not saying that this differential equation doesn't have solutions. In fact, it does have solutions, but we just can't write formulas for them. Okay, let's look at another example of a separable equation that causes some trouble. So this equation is clearly separable. We can separate both sides. So on the, let's separate our variables. So we get y sine y equals x squared minus 1 dx. Sorry, I missed my dy here. There we go. Now we can integrate. Okay, on the right-hand side, we're going to get 1/3 x cubed minus x plus a constant, so that's no problem. On the left-hand side, it looks like we're going to have to do integration by parts, right? This is a classic case for integration by parts when you have a variable times a trig function. So let's see, we're going to get minus y times cosine y plus the integral of cosine y dy. So we get minus y cosine y plus sine y equals 1/3 x cubed minus x plus c. Okay, so we were able to do the integral that time. That's good. But remember, the next task that we have to do to explicitly solve for y is solve this equation for y, or solve this algebraic non-differential equation for y. But this equation, we aren't going to be able to solve this for y. When you have a y that's inside a trig function and outside a trig function, usually you're not going to be able to solve this for y. You know, if we had a particular x value on the right-hand side, we could approximate a solution for y, but there's not going to be a formula we can write down for y here. The equation that we get is just too messy to solve. So we were able to do the integral, but then we couldn't solve the resulting equation for y. So again, we can't make any further progress. Now, again, I'm not saying that there is no solution. In fact, there are lots of solutions to this differential equation. We just can't write down an explicit formula that looks like y equals some function of x. Right? This is what we would really like, but we aren't going to be able to get that in this case. Since we were able to do the integral, this big equation that we can't solve for y This is a solution, but it's not an explicit solution. This is called an implicit solution, because it doesn't explicitly tell you what y is. Instead, it sort of implicitly describes y, right? Sometimes an implicit solution is good enough, but what you'd really like usually is an explicit solution. But if you can't solve the equation for y, you're stuck with an implicit solution. If we could graph this thing, what we would see is that whatever the graph of this is, it usually isn't a function. So, I don't know what the graph of this looks like, but, maybe it is something like this, where it doesn't pass the vertical line test, and so you aren't going to be able to solve this for y just because it's not a function. Y isn't a function of x in this case. Okay, there's one other way that it's sort of common for this separable equation idea to fail, and here's an example. So dy dx equals y times x minus e to the x, and so our first job is to separate by multiplying or dividing, but if you look at this differential equation, the right hand side here, this isn't a function of x times a function of y. So if we try to separate the variables, so one thing we might do to try to separate the variables is multiply both sides by 1 over y, maybe. So on the left hand side we get 1 over y dy dx equals, on the right hand side when we multiply by 1 over y, we're going to have to distribute that 1 over y. We get x minus 1 over y times e to the x. Well, we still have y's on the right-hand side, so we haven't made any progress here. Another thing we could try is, so let's start over with dy dx equals yx minus e to the x. Another thing we could try is maybe just moving this yx term to the left-hand side. So minus yx plus dy dx equals minus e to the x. But this hasn't separated our variables either, because we still have an x on the left hand side. I guess maybe we could try multiplying both sides by 1 over x. Well, we're going to have to distribute this 1 over x, and when we do that we get minus y plus 1 over x dy dx equals minus e to the x over x. So, but again, still we have some x's on the left-hand side. So what we're seeing here is this differential equation, we can't separate it. It's not separable. It's impossible to write this right-hand side of this differential equation as a function of x times a function of y. It's just impossible to rearrange this differential equation to make it look separable. So this differential equation isn't separable. And you can see if you try to separate a non-separable equation, it's just impossible to separate. What you have to resist the temptation to do is you have to resist the temptation to try to separate so hard that you make algebra mistakes. So it's sort of a common mistake that I see for, especially with someone who's just learned how to separate or how to solve separable equations. It's sort of common to see algebra mistakes like this. Well, let's multiply both sides by 1 over y, and then these cancel, and then we have 1 over y dy dx equals x minus e to the x. But, and then we can finish separating by moving the dx. But this was an algebra mistake, right? Right here, I was supposed to multiply the entire right-hand side by 1 over y. I can't multiply just one piece of it by 1 over y. So, this resulting equation isn't the same as the one we started with, so this isn't right. There are lots of different variations on algebra mistakes that make non-separable things look separable, but just be on your guard to not make those algebra mistakes so that you don't accidentally turn a non-separable equation into a separable equation. Of course, non-separable equations, we don't have any tricks for solving them at this point, but there are tricks out there.